Hello everyone, I am Professor P.G. Chilveri and I am going to discuss with you about very large scale integration. The very first thing that we should know in very large scale integration is about VHDL modeling. Contents that I am going to cover today is introduction to VHDL, the data objects present in VHDL, and the data types present in VHDL. Let's look at the first point, that is introduction to VHDL. What is VHDL? Basically, it's a hardware description language. The acronym of VHDL, V stands for VHSIC, that is Very Large Scale, Very High Speed Integrated Circuits Hardware Description Language. VHDL is a IEEE standard. It is a standard technology independent language. Applications are FPGA, CPLD and ASIC programming. Means you can model any hardware circuitry in VHDL, that is using very high speed integrated circuit hardware description language. You can build any digital circuit and that you can download on the available platforms like FPGA, that is field programmable gate array, CPLD complex programming logic array, and ASIC programming. Let us see what different data objects present in this hardware description language. Data objects, by using these objects you can store the data in the form of, the first thing is signal, variable and constant. So first we'll discuss about what is a signal. It is just an interconnection wire. It represents a wire. It can be declared, as it's a programming language, we must know where the signal we can declare. The first thing is an entity. We'll have a look at entity and its declaration. What do you mean by an architecture later on. Entity declaration referred by any architecture for that entity. The second is architecture declaration, means you can declare the signal in architecture body as well, like you have in a C program. For example, you have to declare first the main function and then all the functions that are declared in the standard stdio package you can declare in the main function. Similarly, in case of VHDL, you have an architecture body and in that you can declare the signal also, as well as you can declare the signal in package using packages also. And whatever signals you can declare in package, it is considered to be a global declaration. Whereas in architecture, whatever you declare, it is local to the architecture. Let's look at the syntax, in what way we can declare the syntax. So here, the signal, it is a syntax that is used to declare a signal. Then you can declare its name and the type. The type means we'll also look at different data types that are present in the VHDL. So here is the initial value that you can force to the given signal using this symbol, initial value. For example, here is the syntax that is used to declare a signal, that is SIGNAL. Then X is the signal name and bit is the data type and 1 is the initial value that is forced to X, that is signal X. Also you can declare like the another way, signal write the syntax signal, say Y colon the data type, we have another data type, say std underscore logic, std logic, and then you can force it to the value as say 0. So initial value taken by the signal is signal y is going to be 0, which is of standard logic. Next data object is variable. It is used for local storage. It can be declared in a process statement. Rather, it must be declared in process statement only. So this is a very important point compared to your signal and the variable is always declared in a process statement. Process is again a keyword that is used in VHDL and also in subprograms. Let's look at the syntax that is used for variable. So it is again like signal only, variable, variable name and variable type. Also you can force the initial value to the variable using this symbol. For example, variable y std underscore logic is the data type and the initial value is 0. So basic difference if you observe between the variable and the signal is its declaration part. Then we have the constant. The third data object is a constant used for specific value. Means if suppose x, wherever you are referring in the program, is assigned a constant value of say 5 milliseconds, that is a time, then that x value is declared with 5 milliseconds only. It is declared in entity declaration, referred by any architecture for that entity, then architecture declaration, referred by that architecture only, and package declaration. So it is similar to the signal. The syntax used for a constant is a constant name and constant type, and you can force some initial value using this syntax. So a very famous example of say pi has a constant value of 3.14, and this you can declare using the constant data object. In case of VHDL, say pi is a real is again data type that is used for pi because we are using a real value here, that is 3.14. If you compare a signal and variable, variables are more efficient as assignment happen immediately while signals scheduled to occur. So signal assignment is always scheduled in VHDL, whereas variable take less memory while signals need more information for scheduling and signal attributes. Thank you.